All right, number 3, we want to find the value of the test statistic. So since we're using a proportion, this is the z-value that we're going to use. So the formula for the z-value is going to be p hat, so the sample proportion minus the true proportion divided by the square root of the true proportion, 1 minus that value over the sample size, which is n. Okay, so this is what we're going to be using to find that test statistic. So we're given a sample of 1,500. So I'm just going to plug everything in right here next to it. So my sample size is 1,500. So it's going to be on the bottom under the square root. Revealed that 49% of the chips failed in the first 1,000 hours. So the 49% is my sample proportion, my p hat, so 0.49 as a decimal. And then the company's promotional literature states that 47 fail. So the true proportion is 0.47. So 0.47 and then 1 minus 0.47. Or you could go ahead and subtract that and put 0.53. It doesn't matter. So here's what we need to find our sample proportion. I need to pull up my calculator so that we can compute. And with the 83, I need to put the top in parentheses, and then the bottom is going to be in parentheses. So it'll open it up. So you have several sets of parentheses there. But it'll look something like that. So first, clear out what we have. And then I'm going to open up parentheses, and we're going to do 0.49 minus 0.47, and then close, divided by, and then we open parentheses on the bottom, and then second square root, and then we're going to do 0.47, and then I'm going to open it up, parentheses again, and I'm going to type 1 minus 0.47, and then close parentheses, once, twice, that's ending, no, everything's under the square root, so I don't want to close it. I'll just close it once for that one. And then divide it by, because all of this is under the square root, 1,500. And then from there you close twice. One to end the square root, one to end the denominator. So I click submit. Okay, so our value is 1.55. And that is the test statistic rounded to 2 decimal places. 1.55. Okay, so this one is also the same. We want to find the test statistic. So we're going to do the same thing. Hospitals told 57% of visitors are insured. So this time they're giving us the p-value first, or the true proportion. Okay, so I'm plugging everything in again. One minus. Okay, so my true proportion this time is 0.57. And we want to test a claim that the patient's insured is under the expected. So my sample size is 130. So I can go ahead and put the 0.57 here. And then on the top, we found that 65 patients were insured. So I have to find the p-hat this time. So I have to do 65 divided by 130. And that's going to give me my sample proportion. So this is half. So 0.50, or just 0.5. Okay, so if you divide that, that's half. So here's what we're going to be plugging in. So I'm going to pull up my calculator. I'm just going to type over what I have. So I'm going to hit second enter, and that pulls up what I had to begin with. And I'm just going to go all the way to the beginning and just start typing over what we have here. So we got 0.50, and then this is going to be 5.7. So it's kind of saving me some button pushing. And then this is also 5.7, and then also 5.7. And then at the bottom we had 130. So I'm going to type a 3 and just delete one of these zeros. So just double checking. 0.5 minus 57% divided by 57 times 1 minus that, divided by 130. Okay. Should be okay. We get negative 1.61, and that will not round up, so negative 1.61.